All right, nerds. So let's talk about friction. By the end of this lesson, what we want to be able to do is understand the action of friction on an object. How is friction involved in motion or preventing motion? So this is our vocabulary, and we want to be able to pause the video now and scribble this down so we've got it to refer back to as we continue on through the lesson. So friction, right? What friction is it's a force which opposes sliding or rolling motion between an object and any surface, really. And we can see that when we have a push, this is the force here, a push, if there's no motion, we have something called static friction. If there's we have sliding friction or a rolling force, that's still going to cause friction, so rolling friction. But these two we would tend to call kinetic friction. So we have kinetic friction and static friction, which we'll talk to in a minute. But as we see with our free body diagram here, if the push force is going this way, now the push force would be coming from the other side. But remember, that's how free body diagrams work. If you're not sure, just watch the free body diagram video we have in this channel. It goes through it nice and clearly. And the friction force goes in the opposite direction. Now, the force arrow here is smaller than the push force, which means this object here is moving or accelerating actually in this direction. So friction, though, it resists motion. Now, basically it happens at the interface or where they join between two surfaces. So if we've got smooth surfaces, they'll glide over one another fairly easily. If we have rough surfaces, they'll resist that motion. And the rougher the gap between, or the rougher the interface between two surfaces, the higher the friction between the two objects, and the more force is required to make acceleration happen in the first place. So sliding on ice is often used to represent 0 newtons of friction. Now, this is not technically true. There'll still be some friction on ice, but just because of everything else goes on, heating up, melting, refreezing, and so forth. But it is what we use in a perfect world because physicists, they like to simplify things down. Ice is often used to represent 0 newtons of friction. So friction and motion, right? Now, if friction was too low, the runner would slip. Now, if we go back to that ice, that's why we slip as we put our foot down. So as we put our foot down and we push off this way to move forwards, we push backwards so that we can go forwards. As we push back, if there's 0 friction or not enough friction, what will actually happen is that the foot will just slide out and move backwards. So friction, while it resists motion, if the motion is occurring because something is pushing against the ground or rolling against the ground, it needs that friction to start off with to make movement happen. So let's look at our two types of friction. We've got static friction. Static friction is the friction between two bodies at rest. In other words, they're not moving. Whereas kinetic friction is the friction between two surfaces in motion. When we have static friction, it must be more than any push forces. In other words, it's not moving. So the friction has overcome the push force and it's stayed still. Whereas if we've got kinetic friction, it must be less than any push forces. And so what that means is, if you have a push force to make something go, we have to keep applying that force. If we stop applying that force, the friction will slow the motion down. If there's 0 friction, once we push it, it'll keep going forever. But once there's some friction, if we push and we stop applying that force, it will eventually slow down. And you see this if you roll a ball or slide something along a smooth-ish surface. Static friction can be 0. So if there's 0 push force, the static friction force can be 0. Yet when it comes to kinetic friction, it cannot be a 0 force. It's just not possible because there will be some interaction between whatever something is rolling on or moving on and the object itself. Okay, I hope that made a lot of sense. If it didn't, put any questions you have in the comments below and we'll get back to you as quick as we can. Don't forget to hit subscribe and maybe even turn that bell on so you get all notifications. And yeah, thanks for watching. We'll catch you next time. Bye now.